Hello everyone, in this video we are going to solve an AP calculus problem involving temperature, a change model by a function CT. Let's go step by step and break it down clearly. Let's get started. Part A, approximating C prime 5 using the average rate of change, knowing that T between 3 and 7. So we need to approximate C prime 5 using the average rate of change formula. So the formula C prime 5. So C7. So since here T between 3 and 7, so C7 minus C3 over 7 minus 3. This rule. From the table, we see that C7 equals 69 and C3 equal 85. Plugging this value in, so here we have C prime 5, C7 equals 69 minus C3 equal 85 over 7 minus 3, so equal minus 16 over 4. So C prime 5 equal minus 4. Since CT represents the temperature in degrees Celsius and T is in minutes, the units of C prime 5 are degrees Celsius per minute. So here C prime unit of C prime 5 is degree Celsius per minute. So since here we have CT represent temperature in degrees Celsius and T in minute, so the units of C prime are degrees Celsius per minute. Let's move to the part B. Left remains sum to approximate the integral from 0 to 12 ct. So what we have here in part B, integral from 0 to 12 ct dt. So the first step, we divide the interval from 0 to 12 into 3 subintervals. Why 3 subintervals? Because here what we have, because here we have 1, 2, 3, 4. So we can divide it from 0 to 3, also from 3 to 7, also from 7 to 12. So how many intervals here? We have 1, 2, 3. We have 3 intervals. So we can divide the interval from 0 to 12 into 3 intervals. So now the left remains sum formula is, so what's the formula here? The sum width of interval times multiply by what? By left endpoint value. Okay? From the table, we use only the left endpoint. So here we have 0, 3. Where the left point? The left point 0. So we use 0 only because in the question, left remains sum formula. So we use only the left point. So 0, 3, where the left point is 0. So C0, what we have C0 here? C0 equal 100. So what we have here? We have 3, 7. Where the left point? The left point 3. So C3 equal 85. Also what we have here? We have 7, 12. Where the left point? The left point 7. So we use 7. C7 equals 69 in the table. C7 equals 69. Now, the integral from 0 to 12 ct dt approximate. So what we have here? We use this formula. So what we have here? Width of interval. So what the width from this interval, the first interval, the width from 0 to 3. So count from 0 to 3. So 0, 1, 2, 3. We have 3. So right here 3. Also, what we have here times. So right here times, multiply. Also, what we have here left end point value. So what the value the left end point. The left end point here 0. So what the value of 0? The value of 0 100. 100. So times 100. Also, because here we have sum, so we should write here plus. We come to the second interval. So what the width of interval? The width from this interval from 3 to 7. Count from 3 to 7. 3, 4, 5, 6, 7. So I have 4. So we write here 4. Also, what we have here? We have times. So we write here times. What? Times the left end point of this interval. So the value of left end point. Where the left end point is 3. So what the value of 3? 85. So we write here 85. Also, we write plus. We come to this interval. What the width of interval? Count from 7 to 12. 7, 8, 9, 10, 11, 12. We have 5. So right here 5 times. So what the value of 7? 69. So we write here 69. So the answer here equal 985. What does this number represent? What does this number represent? So this represents the approximate total temperature accumulation over 12 minutes. Now, so if we divide this by 12, so this means we get the average temperature over the first 12 minutes. So if we divide this by 12, this the value of this equal 985. So if we have 1 over 12 C0 12 CT dt equal 985 divided by 12. So equal 82.08. So this represents the average temperature over the first 12 minutes. Why? Because integral from 0 to 12 CT, this represents what? The approximate total temperature accumulation over 12 minutes. So if we divide this by 12, like this, so this represents the average temperature over the first 12 minutes. Let's move to the part C. We are giving that T between 12 and 20. The rate of change of the temperature is modeled by C prime T equal this. We also know that C12 equal what? Equal 55, which means that at T equal 12, the coffee's temperature is 55 degrees Celsius. Okay, so our goal is to find C20, meaning we need to determine how the temperature changes from T equal 12 to T equal 20. We can use this rule. So C20, or we write the rule CB equal CA plus integral from A to B C prime T dt. This rule. So we can use this rule. But here, what we have, we need to find C20. So we write here C20. And what we have C12. So we write here C12. Also we have the integral from A from 12 to 20. From 12 to 20, we have C prime. So we can use here A equal 12 and B equal 20. Okay, so here C20, C12. Also here 12 to 20. Now C20 the value of 20 equal the value of 20 equal 55. So here 55, we write here 55. Also, what we have here, t between 12 and 20, c prime equal this. So we can write c prime, the value of c prime this. So here we have integral from 12 to 20 minus 24.55 times exponential 0.01 t over t dt. Also, we can write this like this. So minus 24.55, we can write this here, this number. We can change this and write like this. So equal minus 24.55 integral between 12 and 20 exponential 0.01 t over t dt. How we can find this integral? We can use the rule change of variable. So what we have the variable here, we can write the new variable u, for example u equal 0.01 t. So du, derivative of u equal 0.01 dt. So the value of dt, what the value of dt? So dt equal du over 0.01, okay? So dt here equal du over 0.01. Now, so let's calculate this. So here we have minus 24.55 integral. Now, 12 is gonna be what here? So for when t equal 12, when t equal 12, u equal 0.01 times here times t. So times 12. So equal 0.12. Also, when t equal 20, so here t equal 20, when t equal 20, so we use we use the change of variable rule, change of variable. Okay. So when t equal 20, change of variable u equal 0.01 times 20. So equal 0.20. So 0.2 or 20. Now, so we write here instead 12, we can write 0.12. And instead of 20, we write 0.2. So here 0.12 because we use the rule change of variable. And here 0.2 exponential. So change the variable here. 0.01 t equal what? Equal u. So we write here exponential power u. dt equal what? dt here equal du or du over 0.01 dt. Sorry. Also here we have t. So how we can change t to u? We use this. So t equal u over 0.01. So instead t here, we can write instead t, we can write equal u over 0.01. So here instead t we can write u also over 0.01. Here we can simplify 0.01 and 0.01. So this is gonna be, I want to erase it here. We get this, but here we do not have elementary antiderivative for this. But we can use this rule if we have integral from a to b for eu over u du. We can use this rule equal ei b minus ei a. So how we can find ei B and EIA. So here A equal what? A equal and B equal 0.12 and here 0.20. So B and A 0.20, 0.12. So how we can find EI 0.12? By using mathematical software, for example, Python or MATLAB or any application. Because E I U equal gamma plus ln U plus sum k equal 1 to l'infini uk over k times k factorial. So it is difficult to find this manually. It is very difficult. So we can use the MATLAB or Python or any software, mathematical software. Okay. Now let's move to the part D, determining if the temperature is changing at an increasing or decreasing rate. Finally, we are given C double prime T equal this. To determine if the temperature is changing at an increasing or decreasing rate, we analyze the sign, only the sign of C double prime T. So the numerator, what we have in the numerator, we have 100 minus T. Is positive, this positive for T smaller than 100, because if T is smaller than 100, so 100 minus T is positive. And T here, what we have T is between 12 and 20. So T is smaller than 100. This means 100 minus T bigger than 0. This is bigger than 0. Also here we have this exponential. Exponential always positive. So here always positive. Exponential. Power any number. In the denominator, what we have in the denominator, we have t power 2. So this also bigger than 0. This means c double prime t bigger than 0. The function is concave up, meaning that temperature is decreasing at decreasing rate. Okay, because c double prime bigger than 0, so the function is concave up, meaning that temperature is decreasing at the decreasing rate. I want to explain this more clearly. Okay, so what we have here, if we have C prime T smaller than 0, this means the temperature is decreasing. But if the C double prime T positive, this means the decrease is slowing down. Okay, and if the C double prime T smaller than 0, this means the decrease is speeding up. Okay, this is the first case. Second case, if we have C prime T positive, this means the temperature is increasing. But if the C double prime, in this case, okay, if the C double prime positive, this means the rate of increase is speeding up. Okay, speeding up. And if the C double prime T is negative, so the rate of increase is slowing down. Okay, here in this question, we have the C prime. What we have C prime? C prime is negative. So here, in this case, we in this case, okay, in this case, so C prime negative. So this means the temperature decreasing, but C double prime, what we have C double prime? C double prime positive. So if we have C double prime positive and C prime negative, this means the temperature decreasing, slowing down. Okay,